Hey everybody, welcome to 12.5 part 3, which is going through numbers 9 through 11, which I would consider finding the equation more in a word problem format. So our goal is to try to find the equation of this first parabola, number 9. And again, visualizing on a graph is so helpful. So I have a parabola, vertex at -1 up 3, and a focus at 2, 3. So if this is my vertex and this is my focus, I know that the distance from the vertex to the focus is really defined as p. So this distance of p would be 3 units. And so in order to find the equation of a parabola, I first need to decide what kind of parabola it is. If the vertex and the focus are next to each other horizontally, that means either my parabola is facing this direction or facing this direction. Now, because the focus is always inside the parabola, if I draw a quick sketch, my parabola is going to be facing this direction, which means that it is a wide squared base parabola, and it is a positive y squared because it is facing to the right. So what we've determined already is that the p-value is 3, because that's the distance from the vertex to the foci. And so if I write my general format, y minus k squared equals 4p times x minus h, not squared because a parabola only has one term that's squared, is I would need to find my vertex, which I have. So I have h and k, and I have the p-value. Awesome. So I'm almost done with this one already. So my equation would be y minus 3 quantity squared equals 4 times 3 x minus -1, or more simplified, y minus 3 squared equals 12 times x plus 1. So this would be the equation of my parabola that is going towards the right, and my y is squared. Number 10, the ellipse. This ellipse has vertices at 5, 0 and 5, 12. See, over 5 up 12, so all the way up here somewhere. Because my vertices are up and down, this to me means that my ellipse must be a vertically based ellipse. It also tells me that the minor axis is of length 10, and we'll come to that in just a little bit. But first, I think this is trying to say if my major vertices are at 5, 0 and 5, 12, that means the distance from here to here is 12 units. So my center must be directly in the middle of those 2 points. So 1, 2, 3, 4, 5, 6. And then if this is 12, 1, 2, 3, 4, 5, 6. My center must be at the point 5, 6. And because I think this is a vertically based ellipse, if I write my general formula, x minus h squared, y minus k squared equals 1, my a squared would be under the y because it's vertical, and my b squared would be underneath the x. So I already know my center. I actually already know my a value because the distance from here to here is 6, and from here to here is 6. So a is 6 units. I would just need to find my b value, and that comes from the fact that I know that the minor axis is of length 10. So if my minor axis is of length 10, that means I'm going 1, 2, 3, 4, 5 in each direction. 1, 2, 3, 4, 5. So that means that my b values must be 5, because that's the distance from the center to the minor vertices. So if my b is 5, my a is 6, and this is my center, my equation would be the following. X minus h, which is 5 squared, over b squared, which is 25, plus y minus 6 squared over a squared, which is 6 squared or 36, would equal 1. So this would be my answer for number 10. Finally, number 11 is a hyperbola. And here is, at least to start, let me draw my vertices. And remember, a hyperbola only has one set of vertices because you have to make a little rectangle to draw this. So my vertices are at -2 up 1 and 2, 1. Because my vertices are next to each other left and right and not up and down, that means that I have a horizontal hyperbola. And I notice that the problem says that it also passes through the point 4, 3. So if I'm going to be careful about it, my picture would look something like this. I'll try to do the same thing on this side also. And again, the pieces are facing left and right, which is why this would be a horizontally based hyperbola. If I would like a horizontally based hyperbola, my equation is eventually going to look like this. X minus h squared over a squared. This is first because it's horizontal, minus y minus k squared over b squared equals 1. So that's what I want in the end. But I need to find some other information first. I can find what a is, because again, that's the distance from the center, which is going to be right in the middle of those vertices, both directions. And that distance is 2 each direction. So I know that my a value is 2. I know that my center now is 0, 1, because it's in the middle of my vertices. Now I don't know what my foci are, unfortunately, so that means I do not know the distance of C. And if I do not know the distance of C, I can't use the Pythagorean theorem to find B. So, well, we're going to have to solve this one a little bit differently other than the Pythagorean theorem to find B. So there is a reason that the problem gave you 4, 3. Now I wrote something up here already that if you're given 4, 3, you're really given the point x, y. So we can plug these in and work backwards. Let me show you what I mean. I know that this is really x minus h, which is h, k. So x minus 0 squared over a squared, which is 4, minus y minus k squared over b squared equals 1. If I simplify this down a little bit before we plug in x and y, x minus 0 squared is just really x squared. So I have x squared over 4 minus y minus 1 squared over b squared equals 1. Because again, I don't know the foci, I can't do the Pythagorean theorem. So let me plug in 4 for x. So I'd have 4 squared over 4 minus y is now 3 minus 1 squared over b squared equaling 1. I'm just going to keep moving down here. 4 squared is 16. So 16 divided by 4 is just 4. Minus 3 minus 1 is 2. 2 squared is 4 over b squared equals 1. If my goal is just to figure out what b squared is, we can subtract 4 from both sides. We'd have negative 4 over b squared equals negative 3. And if you think of this as a cross multiplication problem at this point, we would get negative 3 times b squared equals negative 4. If we want to get b squared alone, we have positive 4/3. Now I could take the square root, but I don't really care about the square root because all I need to know for the equation is what b squared is. We found that b squared was 4/3. So here would be my final answer for this problem. We had x minus 0 squared over 4. So the first part is x squared over 4 minus y minus 1 squared over b squared now, which is 4/3, equals 1. And so notice the equation went back to being general. We wanted it that way. The only reason we plugged in x and y here is so we could manipulate and figure out what b squared was. But then, like any equation, you want the general answer. So here is my final answer for number 11. All right, guys, thank you so much for sticking with me on all 3 videos. I hope that separating them made it easier to focus on the types that you need more help with. Before I go, remember that the reason we want the fraction in the denominator is we do not want a coefficient in front of anything on top. That's why it's a fraction down here. Feel free to rewatch any of these videos, and I hope they are helpful to you when you study. All right, guys, thank you so much.